Hi everyone, this is Mrs. Van Horn, and this is the first of the recording for IM2 Distance Learning Week 3 live lesson. What are we doing today? We are graphing quadratic equations by counting when a is not 1. We're going to venture into a new unit called circles, where you will be looking at area, circumference, central angle, and its arc length and sector area. To begin, everybody got to do a warm-up problem, and this was important because you're going to have a quiz at the end of this class. And if you, for some reason, you're watching this because you were absent from the class, you need to contact me as soon as you can so that we can arrange a make-up quiz. Otherwise, you will get a 0 on your quiz and it will bring down your overall grade. So here are the warm-up problems. You are supposed to graph the equations. The first problem, this is very similar to the quiz that you're going to have at the end of today. These two problems are going to be very similar to the quiz you're going to have next week. So, like I said, graphing quadratic equation, today's quiz lasts 5 to 7 minutes of the class. Next week's quiz will be finding the equation from graph or table of data. You will also have a challenge extra credit problem, converting standard form of quadratic equation to vertex form. Quick feedback on homework. How was last week's homework? For this week, you only have one homework. Yay! Well, the reason is that I'm hoping that you will use this time to catch up if you are behind. So, a quick recap of last week's lesson. We learned a new method of graphing by counting from the vertex. So you find the vertex first, and then you figure out that the next point is going to be 1, 1, when a is 1, or 2, 4, or 3, 9, and so forth. Whether you go up or down depends on whether a is positive 1 or negative 1. In this case, a was negative 1. So that is the reason you went down. Another method you learned is stepping method. So instead of starting from the vertex every single time, you are going from 1, 1, and then from that point, next point will be 1, 3, 1, 5. And this works again when a is 1 only. And so the vertical change increase in odd series. So 1, 3, 5, and 7, and so on. We also learned that because parabolas are symmetrical, we only need to plot one side of the line of symmetry. So once we plotted the right-hand side, then we can use the fact that they are symmetrical to find the other points on the other side. We also then went on to speculate, okay, what happens when a is not 1? Say when a is 3. Comparing these two equations, they have the same vertex. But the a value is different. So what happens where I went 1 to the right and 1 up for the green where a is 1. For the purple, I went up by 3 instead of 1. Similarly, where I went 2 to the right and then 4 up for the green, I went 2 to the right and 12. 12 being 3 times 4. Where did the number 3 come from? That's the a value. And likewise, where I went 3 to the right and 9 up, instead I went 9 times 3, which is 27. I went up by 27. So the vertex form, the a value, the 3, tells us how much I need to multiply that number by. So they both have the same vertex, but the blue graph is vertically stretched by the factor of 3, and we call that a value as a stretch factor. Okay, so now you know how to graph when a is not 1 as well. Okay, so when a is 1, the value increased by 1, 1, 1, 4, 1, 9, and so forth. But when a is not 1, the vertical change is going to be multiplied by whatever the a value is. So now that you know how to graph easily using the vertex, you are going to try the warm-up problems. Please pause the video and do this problem yourself. I will be showing you the answers in a minute. So here is the worked out solution to the warm-up problem. The first question asks you to graph the following equation. Y is x plus 2 all squared minus 3. So this is in vertex form. So that means it's very easy for us to figure out what the vertex is. Vertex is going to be the opposite number. The x value is going to be opposite number to the number in the parentheses. So the vertex x value is going to be opposite of 2, which is negative 2. And this, the k value, is my y value. So it's going to be negative 2, negative 3. So starting from negative 2, negative 3, I need to put my negative 2, negative 3. This is my vertex. And now let's look at the a value. What is the a value in this case? A value is 1. So that means it's simple. I need to go 1, 1. That's my next point. And then from here I can go 2, 4 up. Or I can go from this point, I can go 1, 3. And that's my third point. And then from here I can go 1, 5. 1, 1, 2, 3, 4, 5 up. So now I can use the fact that they are symmetrical to find the other points on the other side of the line of symmetry. Now that I've plotted them, I can join by using a nice curved line to draw my parabola in. And now it's done. And notice the fact that the x-intercept are not a whole integer, but this method is really easy because I don't even need the x-intercept. Okay, so then let's look at the next problem. The next problem is in intercept form. What is easy to find from the intercept form? It's the x-intercept. That means that I can very easily find the x-intercept by setting the factors x minus 4 is to be 0 and x plus 2, that's the second factor, to be 0. And then from here, adding 4 to both sides, x is 4. And from here, subtracting 2 from both sides, x is negative 2. So I can very easily say the x-intercepts are 4, 0, and negative 2, 0. Okay, but we want to find the vertex because that's going to help us to figure out the graph it really easily. So how do I find the vertex? So for x coordinate, x is going to be the average of the two zeros. Okay, 4 plus negative 2, 4 plus negative 2 divided by 2. 4 plus negative 2 is positive 2 divided by 2 is going to be 1. So I know the x coordinate is going to be 1. To find the y coordinate, I substitute the x value to the original equation. That's going to be 2 times 1 minus 4, 1 plus 2. 2 times 1 minus 4 is negative 3, and 1 plus 2 is positive 3. So negative 3 times 3 is negative 9 times 2 is negative 18. So my vertex is 1 comma negative 18. Okay, so 1 comma negative 18. Negative 18 is pretty far down, and my graph is not going to extend that far if I use single unit as my scale. So I'm going to change my scale to negative 2. We're going to go by 2's. And so on. And just to make it easier for us, let's go by 2's for the x-axis as well. Although it does not have to be the same, x and y can be different in scale. But just to make it a little easier for me, I am going to make it the same. So 2, 4, 6. Okay, now I need to plot my points. So 1, negative 18. 1, negative 18 is right here. Then from here, let's look at the a value. A value is 2, that means where I go 1 to the right and 1 up, instead of going 1 to the right and 1 up, where I go up is going to be multiplied by 2. So 1 to the right and 2 up. So that's going to be my value here. And where I go 2 to the right and 4 up, 4 times 2 is going to be 8. So I need to go all the way to here. And where I go 3 to the right and 9, 9 times 2 is 18. So instead I need to go all the way to 18. And notice that this point I just plotted using this 1 up, 1 right, 1 to the right, 1 up method. But notice that it matches with 4, 0 and negative 2, 0 that I found before as well. Okay, so that will be another way to check that, to make sure that your method is correct and your vertex is correct. And I have now drawn my graph. Okay, all right, let's look at the final problem. Okay, here we go. So now this is in standard form. How do we find the vertex easily? Well, you can factor it. Some students are factoring and then find the zeros and then find the x-intercept. That's not easy. Instead, we can use x-intercept is going to be, not x, x value of the vertex is going to be negative b over 2a. That's the formula that we've figured out. So that's going to be negative b is negative of b is negative 6. So I am using parentheses so that I don't lose any of my negatives. A is negative 3. So that's going to be 6 divided by negative 6. So that's going to be negative 1. So my x value of the vertex is negative 1. Let's see what y value is by substituting that into the equation. 3 times negative 1 all squared. Notice that I am using my parentheses to not lose my positives and negatives. So negative 1 squared is 1 times 3. Negative 3 is negative 3 minus negative 6 times negative 1 is positive 6 plus 4. So that's going to be 10 minus 3 is going to be 7. So my vertex I found to be negative 1, 7. So let's plot that now. Negative 1, 7. Negative 1, 7 will be right here. Okay, notice that this time a is not 1, but it's 3. It's not just 3, it's negative 3. That means instead of going up, we're going to be plotting down. So where I went 1, 1, normally when a is 1, I would go 1 times 3 is 3. So I need to go down by 3. That means this will be on my other point where I went 1. And instead of going 4 down, I need to multiply 4 by 3 is 12. So this is 7 here. 12 will be another 5. Oops, that will be here. Okay, and now where I went, instead of 3 to the right, that will be 9 down normally. 9 times 3 will be 27. Let's see, do I have enough for 27 here? That's 7. I need to go down. Oh, okay, we have all the way to the bottom here. Okay, all right, so then I join these points. And I have my graph. Okay, I am going to stop it there. I will show you the answers to the other problems in a minute. For problem 2a and 2b, I am just going to display the solution. So please pause your video and have a look at that. That's 2a and this is 2b. Okay, this is the end of the video. Please watch the second video.